we've been asked to integrate from 0 to 1 minus natural log of x. And this is a type 2 improper integral, because if I think about the graph of the natural log of x, and better that, minus the natural log of x, I get a graph that looks something like that. And so from 0 to 1, I see there is a vertical asymptote at 0, making this an improper integral. So I'm going to rewrite it using the variable a. So limit as a approaches 0 from the right-hand side, and then an integral from a to 1. Well, one of the things I want to notice is that minus can be pulled outside of my integral, and it can also be pulled outside of that limit. So I'm just going to go on and do that, and just let that minus hang out there at the front through most of the problem. And at the end, I'll just remember I have an opposite symbol sitting out front. So now I have the integral from a to 1 of the natural log of x. Okay, well, maybe we actually just know an antiderivative for the natural log of x. If we don't, we can integrate by parts. Picking our u and our dv to be the natural log of x and dx respectively, I can differentiate and integrate. And now I can proceed using the integration by parts formula. So I have u times v minus the integral of v du. Well, those multiply very nicely. And I need to remember I still have an a to 1, and here I still have that a to 1 as well. Let's use a different grouping symbol there. All right, so still taking a limit, minus the limit as a approaches 0 from the right. And I have x, the natural log of x, minus x evaluated from a to 1. Now I can go back to using that grouping symbol there. I need to plug some things in and evaluate a limit. So if I plug in a 1, well, the natural log of 1 is 0, so that bit would go away. And I have a minus 1, minus, and now I have to plug in a into everything, so I get a times the natural log of a minus a. All right, let's leave that minus out front. A approaches 0 from the right. And let's just see, a minus a, that would be a minus 1 minus a times the natural log of a. All right, well, a is going to 0, so that's just going to go away. And that 1, I could imagine it just going on and evaluating the limit, because that's just going to be a minus 1, really a plus 1. Minus the limit as a approaches 0 from the right of minus a, the natural log of a. Bring that minus out front, and that's just 1 plus whatever this is. So I need to evaluate that limit. And just let that 1 hang out front. And this limit is a approaches 0 from the right of a times the natural log of a. Well, when I look at that limit, I try to evaluate it, I get a 0 times infinity. That's an indeterminate form, and I remember that from my Calculus 1 class. And so there's one particular rule for evaluating limits that I'm thinking about. I'm thinking about L'Hopital's rule. And if I rewrite a as a 1 over a on the bottom of the fraction, now I have this in an infinity over infinity form. And I can just use L'Hopital's rule to evaluate that limit. The derivative of the top is 1 over a. The derivative of the bottom is minus 1 over a squared. So you have 1 over a times a squared over minus 1. And let's just say that one of the a's cancel, and I end up with a minus a. As a approaches 0 from the right, that goes to 0. And that improper integral, type 2, that we started with, converges to 1. And that's kind of nice.